All right, good morning, everybody. It's Tuesday, April 21st. We're doing Unit 12, Lesson 3 today. Again, we have our quiz coming up on Friday. I just kind of outline the rest of the week for you. Again, this is today, 12/3. The next 2 days will basically be like if we had work days in class, catch up the 3 lessons of homework and to work on the practice quiz. Thursday will be kind of a work day, kind of Q&A. I'll be on live a few times during the morning for you to log in, come find me, ask me questions on stuff that's going to be on the quiz on Friday. So again, trying to keep this as normal to a class routine as we can. New lesson a day, work day tomorrow, practice quiz review day on Thursday, quiz on Friday, and then we'll pick up lesson 4 again next week on Monday to get ready for the test. Not really sure when I want to put that yet. Haven't really decided. Similar to a class schedule, but a little slower. So, all right. So for 12/3, we're adding a different type of angle in our circles now. We've done the central angles, that their vertex is at the center, and the arc is the same measure as the angle is. So today we're adding in inscribed angles. Right? And for inscribed angles, the vertex is on the circle, the sides of the angle are chords, and then it makes and intercepts an arc, just like a central angle would. The difference is for an inscribed angle, that arc, right? That arc is going to be twice of the inscribed angle, or the angle is going to be 1/2 of the arc, right? The angle's half of its intercepted arc, right? So for our first example, we're trying to find the measure of angle ABD, right? So we're looking to find this angle here, ABD. Well, if its intercepted arc is 124, that means that angle is going to be half of that. So that means that angle is going to be 62 degrees, right? Half of whatever its arc is. All right, finding the measure of angle, or I'm sorry, measure of arc EFG. So arc EFG is when it starts at E, goes through F, and around to G. Well, the angle that makes it, right, is intercepted angle, or inscribed angle, is EHG, which is a right angle. So the arc is going to be double that, or 180 degrees. All right, find the measure of angle T and the measure of angle R. All right, so here's angle T, angle R will be over here. And if you look at the sides of T, it makes this arc that's 66 degrees. So that means this is going to be half of that at 33 degrees. If you look, R actually makes the exact same arc, right, of 66 degrees. So it also is going to be 33 degrees. Okay, so the angle, the inscribed angle is half of whatever the arc is. Okay, example 2, what are the values of A and B? All right, so A is that arc, B is going to be the angle PRS, right there. All right, so angle A goes from P to T. So that arc is created, if you look, that arc is created by that inscribed angle. So that means that arc is going to be twice the angle. So A is going to be 120 degrees. Okay. So then if we're trying to find angle B right there, well, that inscribed angle makes that arc that goes from that point around to here, right? Which is basically the sum of A and 30. So that whole arc is 150 degrees. So angle B would be half of that, right? So half of 150 means that this would be 75 degrees, right? Half of 150. because the inscribed angle is half the arc. All right, corollaries to the inscribed angle theorem. So this is just a couple little things that go along with that inscribed angle theorem we talked about. Right? All right, first one. If you have two inscribed angles that intercept the same arc, then those two angles are congruent, right? Well, that's basically what we did up here for example 1C, right? Where we had to find T and R, and they were both the same thing because they both made the same angle, right? So an angle inscribed in a semicircle is a right angle. So that tells us a couple things, okay? First, in this case, it doesn't tell us that EG is a diameter, right? We don't know that because it doesn't mark the center point. We know it's a diameter if the center point of the circle is marked, right? So in this case, it tells us that EG is a diameter since it makes a right angle, right, for EHG. That lets us know that EG is a diameter. And then conversely, if it gives you that EG is a diameter, then you know that EHG would be a right angle. Right? You can ignore the big circle there. It doesn't really matter. It shouldn't have been there. Opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay? So that would be that, for example, for this one, angle D plus angle B equal 180. Right? And the reason for that is if we look at angle B here, it cuts off the arc from A to C going that way. Right? And then if we look at angle D, it cuts off the arc from A to C going the other way. So basically those two angles make up the whole circle. The full circle is 360, inscribed angles are half, so that means they're going to equal to 180 when I add them together. Right? So that's any two opposite angles in opposite angles of a quadrilateral that's inscribed in a circle. All right, a couple more examples. What is the measure of each numbered angle for A and B? Okay. Well, again, here's where we were talking about with the diameter having the dot, right? So we know that dot is the center of the circle. So we know then that this is a diameter. So we know lots of things because that's a diameter, right? We know that's a semicircle. So that's 180 degrees. We know angle 1 is going to be a right angle, right? Because it inscribes a semicircle, right? So knowing that's 180 could help us with a lot of other things as we go through this problem. If you had other angles in places, right? We could get that this is 140 for there, right? 70, and then we'd have 110 for that arc. So we can find out a bunch of things depending on what they're asking us for. All right? Next one. Find the measure of angle 2. Okay, well, this goes back to the corollaries again. If this angle is 38, it inscribes the arc from there to there, right, which is actually the same arc that angle 2 inscribes. So that means those two are the same angle. So this is 38 degrees too. Okay, the measure of an angle formed by a chord, formed by a tangent and a chord, is half the measure of the intercepted arc. So it's the exact same thing. Okay, it's treated just like an inscribed angle. Just like if we had that inscribed angle, this angle would be half of that arc, right? Just because it's a tangent doesn't change the rules. It's still half of the arc that it inscribes. All right, so SR is a tangent. PQ equals 212, PMQ equals 212. What is the measure of angle 1? Okay, tell us PMQ is 212. So that's from P to M to Q is 212. Okay, so that's the long way since it's PMQ. Okay, so that means we have to find, and we're looking to find angle 1. Right, so there's two ways to go about handling that. we can figure out that angle 2 is going to be half of 212, which would be 106. And then since SR is a line, right, at point Q, those are going to be supplementary angles, right? So, because it's a linear pair. So angle 1 would wind up being 74 degrees. Okay, that's one way. The other way you can look at it is that if PMQ is 212, well, if I go PQ the other way around the circle, this direction, the short way, right, it's going to complete the circle, which is 360, which means that arc is 360 minus 212. So that would be 148, right? And then angle 1 would be half of that, which gives me right back to the 74. Okay. So either way, there's a couple ways to go about a lot of these problems. Just depends on how you want to look at them. Okay. Last example, it's kind of blurry. It's tough to see, but we're gonna get through it. Find the value of each variable. For the circle, the dot represents the center. Okay, and that's mainly just so you know that none of these are diameters. Okay, this one is 98, 96, 120. Okay, this is a common problem that's going to pop up on quizzes, homeworks, tests, right? So get used to it. You're gonna see it a lot. You're gonna have to find certain angles to find other things first, right? So you can't just kind of pick and choose. You're gonna have to know certain letters to find the other ones. All right. The easiest two to do first, actually, are C and D. Okay, because that goes back to what we looked at earlier. That opposite angles in a quadrilateral inscribed in a circle are supplementary. Okay, so that means 120 and D are supplementary, which means D then is going to be 60 degrees, right? And then C would be 84 degrees because it's supplementary to 96. Okay, so those two are the easier ones to get through. Okay. Next, if we look at 120. Our angle that's 120 inscribes or cuts off whatever that angle or that arc, right? That goes from there all the way around to there. Okay, and that's where A is. Well, that whole arc is going to be double 120, so 240. Okay. Well, to find out what part of it is A, we would have to subtract 98 from that. Okay, so we're going to subtract 98 from 240. So 240 minus 98, so give me 142 for A. Okay, so now once I know A, I'm going to have to, depending on how I want to find B, there's several ways to go about it, right? One is I could take angle C, and angle C cuts off the part of the circle that's A and B combined, right? So if C is 84, we would double 84 and get 168 degrees, right? 168 degrees is going to be A and B combined, okay? So then we would take and subtract 142 from 168, and that's going to give me what's left for B. So B would then be 26 degrees. Okay. So again, you're not going to get one angle that's going to give you one of these arcs. You're going to have to subtract away part of an arc based on whatever its inscribed angle is. Okay. All right. So that again is it for the notes today. You have 2 assignments on MyMathLab. The 12-3 homework is going to be open, and the Unit 12 practice quiz is going to be open, and the Unit 12 quiz is going to be on Friday. Okay. Again, I'll give you some more details on that probably tomorrow or Thursday as far as the number of attempts and things, but it will be something that's open the entire day for you to work on. You're not going to do it in one sitting. You can do an attempt and come back, and I kind of expect most of y'all to do pretty well on that. Okay. So if you have any questions before we go live on Thursday and talk, feel free to email me, ask me in Google Classroom, whatever's easy for you. If you have questions, definitely ask them. I can, we can set up a chat if we need to before Thursday. I can work it out and email it to you, whatever we need to do. So again, have questions, email me. If not, I'll hopefully see some of y'all on Thursday.